Nice. All right. Wow, it's so good to be here. Still kind of crazy to realize that we're in Seoul. Very grateful. So thanks to Erica and the team for inviting us. My name is Deniz. I'm known as 0x Deniz online. This is my teammate Adam. We are with Jetstream. Jetstream is an independent product team that's part of the MakerDAO ecosystem. And today we're going to be talking about how to build resilient front ends, because that's what we're focusing on at Maker. We're building open source components that you can use to build and deploy and host and maintain open source front ends for the MakerDAO ecosystem. So I'm really curious, like, how many of you have ever like built some kind of web app or like a front end? A few over there, of course, some teammates, but also some others. Nice, that's good. Because, yeah, I mean, I hope this will resonate and maybe we can have a little discussion after the presentation itself. Before we actually dive into the details, I want to start with some headlines that might be familiar to those of you that are in the Ethereum ecosystem. Yeah, some of these are quite bad, so I actually hope you're not involved in any way. I'm pretty sure you all remember this one. This is the Arbitrum airdrop. Yeah, that's actually not that long ago. So what all of these headlines have in common is that they were all caused by some kind of vulnerability or single point of failure that's not related to the blockchain or the backend, right? The smart contracts were operating fine. There was actually something wrong with either the front-end code or hosting infrastructure, or maybe something like DNS or any tooling that they were using. And it's kind of the point that we're trying to make, because what we've been seeing in the Web3 ecosystem for, yeah, as long as we're in the space, is that there's this hyper-focus on the blockchain and smart contracts being like trustless and yeah, very resilient. But then we build these front ends and these apps, and we're just using AWS, and we're using all of these resilient, or these, yeah, let's say centralized and quite fragile, yeah, infrastructure and service providers. And the thing is, this, if any of those dependencies fail in any way, right? If there's some kind of, yeah, if it's overloading because you have a lot of users, or if there's some kind of vulnerability higher up the stack, then that's actually going to make for vulnerable users. But also the DAO, it can be, yeah, can be at risk. So we actually believe that we need more resilience higher up the Web3 stack, and that's what we're building towards. And the good news is that, yeah, at this point in time, the Web3, let's say, infrastructure and tooling landscape is very rich compared to a few years ago. So yeah, there's actually a lot of ways to build resilient front ends, which is, yeah, what we're focusing on. So we get this quote a lot of times, like, why don't you just deploy your front-end code on IPFS, right? That's like a very like overly simplified statement. I mean, it works if your front-end is very simple and it's just like a static web page for making smart contract calls. But if there's something more complex that you're working on, right? If your app is more complex, so for example, if you have a lot of data sources and you need to aggregate all of the data in the app, and you have to like, yeah, use frameworks, or you're dependent on like dynamic server-side rendering, or maybe if you're like depending on legacy infrastructure, right? If your app relies on things that are still running on Web2 infrastructure, then you can deploy the client-side code on IPFS, but it's not going to really achieve resilience, right? You need a more holistic approach. So our team, we have first-hand experience with this, because we've been working on the Maker governance portal, which is the official governance front end for Maker. It's quite a complicated application, because it's not just a simple front end for making smart contract calls. It's actually some kind of dashboard where people can view all kinds of blockchain data, but also historical blockchain data and like metadata that's not hosted on the blockchain. And it's obviously a very critical application to the health of the MakerDAO ecosystem and also to the users. And yeah, the app, like the V1, was built quite a long time ago, before we were really talking about front-end resilience, and before we had things like, I don't know, subgraphs and things like that, right? So we ended up using centralized infrastructure for some of that, and also things like related processes. So for example, the processes related to managing profile data for the delegates, that's kind of relying on things like GitHub. So if there's problems on any of these dependencies, then that would directly impact our application. And yeah, we've been very aware of that, and I'm very happy to say that the future for Maker is going to be more focused on resilience. MakerDAO has been undergoing this kind of shift on an organizational level, but also on a product level. Yeah, there's going to be more published in the upcoming months, but basically the new strategy is called Endgame. And one of the newfound principles for Maker is to have more resilience, both in the organization, but also on things like front end, and also, of course, on the protocol level, as that's what it's been known for. So yeah, front-end resilience is a default requirement in the MakerDAO ecosystem as part of the endgame strategy. And we're actually pretty sure that this is going to be a default requirement for the entire Web3 space over the next decade. And it's kind of refreshing to see that at this conference, we've already seen quite a few talks about building resilient and composable front ends. I mean, Ilya's talk, that was more focused on the near ecosystem, of course, but it's just very refreshing to see that we're not only talking about the blockchain and blockchain security, but also looking a bit higher up the stack. Yeah, I'm going to hand it over to my teammate Adam, who's going to talk a little bit more about our approach towards building these resilient front ends.
Okay, so if we look at a simple diagram here of your typical Web3 app, you of course have your backend layer, which is going to be the blockchain network of your choice, and then you have the front end layer. And within the front end layer, there's sort of three areas of consideration. You have your application code base. So this is going to be all the code that's producing your UI and contains the logic for interacting with the protocol in the back end. You have your hosting infrastructure. So where is this code living? Where is it being run from? And then you have all the data within the application itself, which informs the user about the protocol and about the transactions that they may be about to make with the protocol. So we can dive into some of these. So when we're building new apps for MakerDAO, we're really focusing on building the app to be compatible across multiple hosting options. So of course, you're going to have your traditional Web2 hosting. This is the default. This is pretty much how all web apps are hosted. And a lot of times when we're using a Web3 app, or an interface, it is still hosted on Web2 infrastructure, which is fine. It works until it doesn't, until there's problems. But so when you're building the app, we think it's important to consider making it compatible for hosting on Web3 infrastructure. So today that's things like IPFS, Arweave, tools like Fleek that allow you to deploy these applications to these types of decentralized like file storage networks. But this is something you want to think about from the beginning because there are some limitations if you want your app to be able to function properly on these in these environments. For example, like you can't rely on having a web server or like doing any kind of server-side rendering for your page. So you're essentially just serving static pages. And so when you're building and designing your app, these are things that you want to consider ahead of time. In addition to using your app on a hosted server somewhere or a network somewhere, we think it's also important to give the user the ability to run the application locally on their own machine and not have to rely on someone else hosting it for them somewhere. So usually this looks like cloning the repo for the project from something like GitHub, doing some small configuration, and then using the command line to run that locally. And if you are familiar with these things, it's usually not super complicated, especially if there's good documentation, but you do have to be familiar with like using a command line, and not all the users have that technical experience. So taking this a step further, we also decided, let's see if we can give people a way to run the app on their machine in a local environment, but so that they don't have to know how to use a command line. And so using a package that was created by Versal, it's called PKG, we actually found a way that you can, from the project, output like a single file that you could then make available for the user to download. And once they have this file, all they have to do is open it on their machine, and the app should work the same way it would work in a hosted environment. So have a short little demo just showing that. It's a really simple script. It basically just takes the built website, like the folder with all the files for the app, and then produces these files that they can run. And if they download that, all they have to do is open the file. It'll open up in their browser on their local host, and assuming it was configured correctly ahead of time, everything should just work out of the box for the user, and it's running on their own machine. They don't have to worry about a hosted instance of it somewhere. So yeah, the takeaway here is like give your user some options, make sure that the app's not only available in one specific place, and if that goes down, then there's no way to access that application. Moving on to the application code base. There's a few things here that are mostly standard best practices in the space, but of course you want your application code for the front end. We believe it should be open source. I mean, these are applications that handle a lot of financial value. Everyone should have an idea of like what code they're trusting when they send these transactions. And it helps to have obviously well-documented code base so that it's easy to read for someone who's just jumping in and wants to see what's going on there. As you mentioned, it should be written so that the configuration is not overly complicated. Hopefully it doesn't rely on like hard to obtain API keys or database credentials, things like that. And then modular and extensible code. So an example of this specific to MakerDAO is that when interacting with the MakerDAO protocol, there's a lot of smart contracts involved, and it requires like a good amount of time to familiarize yourself with all these contracts, which functions to call and how to call those functions, like passing the arguments that are formatted in a certain way. And there's really a lot of overhead there if you're not familiar with it. And so we abstracted a lot of the complex logic into these easy to use React hooks into its own package. So things like interacting with governance, interacting with vaults, DSR, almost anything related to the protocol. We're providing a package of React hooks to make this like pretty straightforward for an average person, or average developer, I should say. And yeah, so if someone wants to make some additions to the existing code base, it shouldn't be that hard, even if they don't have that pre-existing knowledge of the contracts that need to be used. And if you wanted to build a new front end to interact with the Maker protocol in any way, this should make it a lot easier. I mean, you don't have to spend all the time learning about the contracts behind the scenes. So the idea here is make it easy to replicate these front ends, make it easy to make changes for developers. And then lastly, the application data is obviously an important part of the app, and there's a few different types of data that you have to consider when you're loading data into the application. So start with real-time chain data. This is kind of the most straightforward. This is going to be data that you're getting, like the live state of the blockchain. You're getting it directly from an Ethereum node, or yeah, this is typically Infura or Alchemy or something like that. But when you go to an app like Uniswap or something, for example, you don't really have a say in which node that you're sending your data to. It's usually provided by default by the creator of the app. And usually that's fine, but there have been times where like certain nodes go down or certain providers are having a hard time handling traffic. And so we decided it would be a nice feature to have if the user could, in their configuration, maybe set their own RPC node that the application will talk to. So have a short demo for that as well. This is just a page within an app that pulls price data from Maker oracles, which is stored in smart contracts. So it's just a simple call to read a smart contract's value. And you can see that by default, it's going to Cloudflare ETH, which is a public provider. that's available. But if you navigate to our settings page, there's an RPC section, and for each chain within the app, we have an option where you can use the public provider, or you can change that and put in a custom one. And you can actually send a test, make sure things are working. You can see there that it went out to, we put in an Alchemy URL here. And now if we navigate back to our application and go back to like the oracles page, you can see that it's fetching the data, but now it's sending those requests to the RPC URL that we inputted. So yeah, it gives the user a little more freedom into where they want to actually get the data that they're interacting with on the page. Next, you have index blockchain data, which is like your historical data. So these are things that happened on chain, but was maybe a week ago, months ago, years ago, and this data can be pretty difficult to like fetch directly from a node. It's not that efficient. You might have to sift through logs and logs and logs until you find what you're looking for. And so the solution to this on almost every app is that if you know you want this data from in the past, then when it happens, throw it into a database so that next time someone comes to the page, all we have to do is ask the database, like, hey, give us that information. It makes for a better user experience, but like if you think about where that data is sitting, like for us on the governance portal, the solution that we came up with years ago was to have a monitor to watch for these events, and when they happen, we put them into a database. But that database is just sitting on AWS server, and AWS, yeah, it's online most of the time, but it's possible that it could go offline. AWS has had outages. And another thing is that if people want to run their own version of the application, they either need access to this database, so it has to be totally open, or they need credentials to read from it. And it's not easy for them to create their own copy of this database. It's hard to do, and it's also expensive. So we found that a stronger solution for historical data is to use a network of decentralized indexers. There are a number of projects working on this. I think subgraphs from the graph is like the most well-known, at least at this point. And they do have a hosted service, which is basically probably sitting on AWS server as well somewhere, I guess. But they also have a decentralized network that they're building out, which today works. And so we find that this is a much stronger solution for building resilient decentralized front ends, because it's no longer relying on one database sitting somewhere out there that if it goes offline, that data is no longer available. But now it's an entire network of people that are indexing this data for the users. And if a person wants to create their own application for the protocol and wants access to this data, it's there. It's on the decentralized network. They don't need an API key, or they may need an API key, but they don't need like credentials or something. It's an open database for them. So lastly, we have off-chain data, which is a lot of times like used for metadata. An example of this within the Maker context is like for vote delegates. Delegates are represented by a smart contract on chain, which allows people to deposit tokens into it, and then the delegate can vote in the protocol with those tokens. But the contract itself contains no information about who that delegate is. So things like their name, their profile, what they stand for. And people who are delegating their tokens, they want to know this stuff. So we have to find a way to attach information to them. And often it's pretty expensive to put all this data on chain. So people end up using any kind of content management system, really. Like, could be GitHub, could be, I don't know, whatever CMS you could think of. But we used GitHub in the past for attaching data to delegates, and then we have run into issues where either GitHub was down or we were getting rate limited trying to ask GitHub for that information. And so, you know, the smart contracts were still there, but anyone who came to the portal wouldn't know who they're giving their tokens to. So we did some research to try to find for a more like resilient solution to this. And what we came up with is leveraging a decentralized file storage network like IPFS. The reason for this is the barrier to entry for IPFS is pretty low compared to some of the other solutions that are similar. It's very easy to run a node and pin files. And there are also a lot of pinning services available that are not that expensive that you can also leverage too. So you can have multiple IPFS nodes pinning files for you. And then there are also multiple gateways to access this. So you know that if one node goes down, there's likely another one with this file. And as long as it's pinned somewhere, then you should always have access to this file. There's one complication with this is that when you store content on these decentralized file networks, like basically they give you a hash, which serves as a content identifier for being able to find that information or find that file. And it's immutable, and metadata is often changing. So what happens then if you want to update the metadata, someone's profile, or add something new to the file? You can't really modify the file and still have the app know where to find it in the app code itself. So a solution we found is to attach this data about the latest metadata on-chain to something like an NFT. And so like ENS domains are NFTs, and you can attach like text records, content hash to these NFTs. And so we have a system now where every time we update our metadata for the protocol, we send a transaction to a protocol-owned NFT, an ENS domain, and we store a reference to the latest metadata. So when the app loads, all it has to do is check this NFT, get the latest ID for the latest metadata, can fetch it from IPFS. We know that it's going to be available because it's stored on multiple nodes, and this way we have a way to be confident that the app can always have this metadata available, even though it's not directly on-chain. We only have a reference to it on-chain.
Yeah, so Adam just talked about off-chain metadata and also talked about how to use things like NFTs to make that happen in a more resilient way. Another approach we've been looking at is trying to understand how we can potentially move some of that off-chain metadata actually on-chain. There's actually quite some tooling that you can use for this. We're now working with the HATS protocol team to try and understand how we can move some of the governance metadata for MakerDAO actually on-chain. The cool thing is that, so the thing that HATS protocol has built, it's like an NFT standard for tokenized roles and responsibilities. So instead of having some kind of off-chain metadata set that describes all of the roles and like things like names and profile pictures of all the actors in the governance system, you can actually use something like this. So yeah, the truth will always be on chain, and then you can have a subgraph index the HATS tree, and make sure that you always have like an up-to-date version of the truth, right, of the organization in that sense. And you can even take this a step further by then also using this for things like multi-sig access and like maybe even Discord access. So you can really use this as some kind of like way to map out and manage your organization. And what's especially cool about this from our perspective is that you can also have a more granular approach towards managing the metadata, because as Adam said, like the metadata often changes, right? That's the main thing about the governance metadata especially. So if you can have, for example, delegates and voter committees manage their own metadata fields, like, I don't know, like names, biography, that kind of stuff, then it's going to be, you're going to be less reliant on some kind of mandated actor or gatekeeper to manage and upkeep all of that data. And you can do that in a more granular way and also have it represented on chain directly. So that's another thing we've been working on. Yeah, so another important principle here is to be very transparent about which data sources your app uses, and maybe also let users decide which data sources to trust. Like, it really depends on who you're talking to. If you're like talking to some kind of anon dev who is very keen on their privacy, and they really don't like trusting any, let's say, infrastructure layer, then they should have the option to only use those data sources, right? Or at least be informed about the fact that they're using other data sources. We came up with this concept called trust levels, which is a way to like explain to the user the reliance on certain data sources, and also the degree of risk that you're taking, or the degree of trust that's involved for that data source.
Yeah, so we have a quick demo of this concept and what it looks like today, but still evolving. But if we're on our delegates page here, and as the mouse moves around, you see this green indicator. You can click on it, and it says data source information. It tells you this data is not directly sourced from on-chain, but instead from aggregate data from centralized or decentralized indexers. But then it actually lists exactly the source of the data that's on the page. And so in this case, it's coming from a subgraph, and it says trust level 1. Yeah, you can actually go to the source. But if you click trust level 1 to see, to get more information about it, it'll tell you like what trust level 1 means, and then you can view the settings. So here, within the settings, you can read about the different trust levels that we've defined, and you can also change them. So by default, the app has the highest trust level. It basically says we trust anything that the developer has put in here, but it can be changed. You could maybe say like, I don't want anything from like random third party, or go down as far as like, I only want data that is coming from a call to a node, an RPC node out there. And so if we change it back, or we change the level to 0, if you navigate back to the delegates page, now you see these warnings around, and it's pretty obvious, okay, like what is this? And if you click it, it says, this data includes sources that are not trusted by your current trust level of 0. Again, shows you the source, but highlights that like you've said that you don't necessarily trust this data source. And so it's still something we're evolving and working on the UX for, but yeah, the idea is like being very transparent about where the data is coming from.
Yeah, and this is obviously a proof of concept app, so it's still, we're just using this to explain what we're working on, but yeah, we're really looking forward to implementing this further in the app, and also like more granularly, so you can really, I don't know, like hover over any data point that you see in the app and then immediately understand where the data came from. Have a way to easily explain like the amount of trust involved for that data source, and also allow to immediately like view that data file or whatever in a different environment. So yeah, to wrap it up, basically it's all about redundancy, right? So we talked about having compatibility for a range of like hosting and delivery options, so that both the front-end operator can decide like, do I want like a fully regulatory compliant Web 2 hosted instance, but you can also go like the decentralized route and use Web3 tech, or maybe even distribute the app to users themselves so that they can run it locally without any dependencies on hosting. Also make the code very easy to fork and deploy, right? So make sure it's well documented, make sure it's easy to configure, so that you actually don't have to rely on a single instance, and you can expect the community to pick it up and fork it and make some tweaks and actually have some kind of ecosystem. That's really what we're trying to achieve for Maker also. Free your RPC, right? So make sure that you allow people to make changes to which RPC they're using. Maybe even make them aware of the fact that they're relying on an RPC endpoint provider. And for the decentralization maxis, allow them to connect to their local ETH node. Of course, leverage Web3 stack further up the stack, right? So if you're dealing with multiple data sources, try to find a way to not rely on centralized Web 2 infrastructure, which is very prone to things like outages, but also like censorship, and make sure that let's say, platform or tool or infrastructure that you're using, make sure it's redundant, right? For example, we talked about IPFS. We've also looked at some other file storage networks in the space, but IPFS is definitely the most mature one, right? It has a lot of gateways, and there's a lot of redundancy inside of that ecosystem. And that's really what it should all be about. It should all be about redundancy in that sense. And that's what the approach that we're taking for Maker. We want to leave you with this little cheat sheet that we've made. Like, you can use this to assess the, let's say, resilience of any front end in the Web3 ecosystem. So I don't know, if you're in crypto, you use a dApp, maybe ask yourself these questions, try to understand how the app is working, right? And where the data comes from. And yeah, this will make you more aware of, let's say, the amount of trust involved when you're interacting with a dApp, right? Because even in crypto, you're not talking directly to the blockchain, right? Usually you're using this app, which is usually very complex. It's not only like a static front end for making calls. It usually involves a lot of data sources and a lot of reliance on infrastructure. And yeah, I think the first step is for us all to become more aware of this and more critical. And then hopefully, yeah, as we said before, front-end resilience will become a default requirement for the space. Yeah, so if you want to stay up to date about our work and also, yeah, make sure to know whenever we launch the front ends for MakerDAO. Follow us on Twitter, we're JetstreamXYZ. We literally just, let's say, rebranded our team. So we published our proposal to the MakerDAO ecosystem yesterday. It's quite an exciting time for us. Yeah, and we're now happy to take any questions or maybe have a little discussion about the subject. So thanks a lot.